Okay, good morning, everyone. Appreciate you all joining us and welcome to what's hopefully first of many presentations on Chromalox products, designs. This morning we have Charlie Modine. He's got 30 plus years experience in heat trace. Today we're going to talk about the pipe design, heat trace essentials, and go through our Chromatrace program. Charlie has over 30 years experience with the company. He's basically our in-house Jedi, so to speak, for installation, training, design, and he's going to walk through these products for everyone. And with that, Charlie, we're going to hand it over to you.
All right, thanks a lot, Derek. And just to echo what Derek said there, thanks to everyone for joining us here. What we're going to go through first is basic design information that's needed for an accurate electric heat trace design. We have to actually have a form that we're going to step through one section at a time, and it's something you can fill out yourself, or it's something, you know, if you have a client or somebody you want to send it to, have them fill it out, they could do it as well. And it just really covers the basics of what's needed to get an accurate design. So with that, we'll move into the worksheet. It is our form PJ 305-1. You can find it on our webpage. If you can't find it, drop us a note and we'll make sure we get it emailed out to you. But we'll start up at the top of this. We just start with project information. On the project side of it, it's always good to include the project name. This will help with identification and tracking, not only for you, but for us as well. Excuse me, project number. If you have a project number, please include it on this form. Everybody knows that projects go through revisions just like everything else does. So this ties this design information into that project number. The job number is merely there if you want to include, if your client has their own job number or you're going to supply your job number with it, you can add that in here as well. The PO number, we love to get these with a PO number on them. However, at this stage, that isn't always available. So if the information is there, you can put in a PO number, or you could simply write in an inquiry number if you wanted to as well. The drawing reference number, this is whatever document we're getting our information from. If we have an ISO, if we have an ortho drawing, whatever it may be, we'll put that drawing number here just as a reference to go back to say, hey, look, this is where we got our information from. The circuit number information, we only add this in here if there's a specific circuit number or breaker number for this line that you would like designated. And I'll get a little bit more into that here in a minute whenever we get into the Chromatrace program. The line number and pipe number is kind of self-explanatory. If you don't include anything else on this form, if you do use it, please put some type of line number, some kind of identification number for that line. If there's no line number or pipe number, you can just give it a brief description. For example, like a caustic line, 2-inch caustic line from tank 302, whatever, just some sort of brief description that gives this worksheet its own identifier on what line we're looking at. The next section there, and this is where we get into the must-haves that we have to do an accurate heat trace design. The pipe length, and that is what this length is referring to, is the total pipe length. This is not the heat tracing circuit length, just the pipe length. The diameter is self-explanatory. We'll show you in the program. Every option should be in there, but we obviously need the diameter, and then the material of the pipe or the tube that we're heating. This is a must-know for any design. You know, non-metallic piping has special design considerations. Some tubing, you know, tube bundles, smaller type tubes, and even some pipes have exotic materials. All those must be taken into consideration from a heat standpoint. So pipe material is always a very important item to have as well. The next box there covering insulation. We really cannot stress enough the importance of insulation. The insulation type and thickness is critical to any heat trace design. Just keep in mind that every insulation has its own place, be it a wet versus dry location, a low temp versus high temp application. They all have their place and their purpose. Whenever you're designing heat trace, the only thing you're designing heat trace for is to offset the heat loss that is escaping through the insulation. So nothing is more critical than insulation type when it comes to heat trace design. The thickness is huge. It can mean a difference between a 3-watt cable and an 8-watt cable. And, you know, as that may not be a big upfront monetary cost, it is a big cost when it comes to sizing conduit wire, power requirements, total power usage. So insulation thickness, that is something we like to play with a little bit if we have the room to do so. So we always like to ask, you know, well, what is the specified insulation thickness, and do we have any room to play to optimize the design? You know, we have to keep in mind that there always may not be room for additional thickness. Existing pipe, you know, in a pipe rack, you may not have an inch that can increase the insulation thickness an inch because there just physically may not be room for it. And then with the majority of projects now being designed in 3D modeling, the spacing requirements are already there, so the insulation thickness would be a given. Moving down to electrical information, the voltage is what voltage. It's kind of a twofold thing here. What is your preferred voltage, and as well as what is an available voltage? Is there anything else available? If we have 120, you know, it's easy to assume we might have 208 or 240. If it's 480 volt system, then we might have 277. These all make a huge impact on an electric heat trace circuit for circuit length purposes, but as well as for power wire. You know, you increase your voltage, you decrease your amperage, you can use a smaller power feeder going out to your heat trace circuit. If we're talking about multiple heat trace circuits, and maybe combining those into a heat trace panel, this is also a good place to put that feeder supply voltage as well. So if we're going to design a panel with the system, we'll know what the feeder voltage is that you have available. Breaker size, this is there really for one reason. If we only have one size breaker available, let's say it's in an existing lighting panel, and we only have, you know, a 15 amp breaker available or just a 20 amp breaker, then we'll design a heat trace circuit around that, and that affects your total circuit. So that's why breaker size is there. If you go back kind of industry standard for heat trace circuit breakers, it's always pretty much been 30 amps. And where that originated from was when you can only get an EPD breaker up to 30 amps in the past. Well, with our new controls, this has been increased. We increased it up to 50 amps. So we do our ground fault monitoring control within our panel, and we can supply up to a 50 amp circuit through those controls. The breaker type, keep in mind National Electric Code does require ground fault protection on all heating circuits. There are a few exceptions, and they're very few. But as a rule of thumb, yes, you must have ground fault. That's the whole reason for the braid on the outer jacket of the heating cable, is so that you have a ground path if you do have a ground fault. And also keep in mind there's a big difference between a GFCI and a GFI and an EPD breaker. That's why we ask, and it's a good question to ask, is what is the actual breaker type? Control type. This is pretty simple. Are we going to ambient sense it? Are we going to line sense it? Are we going to use a simple thermostat? Or are we going to use a microprocessor-based electronic controller? Keep in mind when you are designing a self-regulating circuit, that just because the heat trace is self-regulating and its output will vary, it never turns itself on and off. So we do recommend the use of control on all electric heat trace circuits. On the next to the equipment information there, all inline components need to be accounted for. These are all heat sinks that require additional cable. And the best example I can give here is a lot of times we'll have somebody ask for, excuse me, 100 feet of cable, and they're tracing 100 feet of pipe. And if they've installed the heating cable correctly, and they've traced inline valves, maybe a pump, maybe a couple of instruments, a drain, a vent, something like that, they're going to be short. So that's where you need to calculate your additional cable allowances for your heat sinks. And I'll show you in the program, everything we're doing and showing you in this worksheet will translate into the Chromatrace program. All right, so temperature information, maintenance temperature, that's a must for obvious reasons. Are we doing a simple freeze protection design, maintaining 40 degrees, maybe 50 degrees in a colder climate, or are we doing a process temperature? You know, is it truly caustic where we need to be up 70, 80, 90, somewhere in there? Or, you know, is it asphalt? Do we need to maintain 300 degrees? So the maintenance temperature is what it is. There's not much variance there, and we should know that right up front. The minimum ambient temperature is nothing more than the minimum ambient for where the heat trace will be installed. This isn't necessarily the lowest recorded temperature ever in that area, but just the average low ambient temperature that heating circuit could be exposed to during the colder months. Minimum startup temperature, this should always match your minimum ambient temperature. The only reason it's an option is if a heating circuit in a heating system is working properly and you have your control set at 40 degrees, then ideally your heat trace should come on at 40 degrees. Well, the problem is if you lose power, you need to go out there on a 20-degree day to try and start up that heat trace circuit. You're probably going to end up tripping a breaker due to the inrush current associated with it. So I always encourage people to design your minimum startup temperature, make that the same as your minimum ambient temperature. Your max exposure temperature, this is probably, like I say here, one of the most unasked questions there is. We've received, I don't know how many hundreds of feet of cable back into the lab that has actually melted on a pipe. Just because, you know, an overexposure situation. So even if you have a max operating temperature of a pipe that may be 150 degrees, there could be a steam out process in place. And the maximum we can go with a self-regulating cable, keep in mind it's a plastic cable, is 420 degrees Fahrenheit. So anything above that, plastic's going to melt. So your max exposure temperature is your absolute worst case, what that cable could be exposed to while taped on the pipe itself. The area information, this is critical, that we know the area classification. It affects your component selection, your design parameters. It affects everything within your design. So know your area classification, and I'll show you in the program. We've got several different options there that we can play with, but always know your area classification. Indoor, outdoor, it's not critical, but it's nice to know. You should probably already know if somebody came and said, look, my minimum ambient is 70 degrees, well, you're probably going to assume that that's indoors, but we need to ask the question. So that's the only reason the indoor outdoor is there. Maximum wind speed, excuse me, standard is 20, or I'll use 20, maybe 25 as a standard. Max wind speed doesn't affect heat loss that much unless you get in extremely high wind conditions in very, very cold climates. So if you do have that application, then let's get the right wind temperature and wind speed in there so we have an accurate design. Corrosives present and corrosives type. This is very important when we select our heating cable. We offer two different types of outer jackets on our heating cable. We offer just a polyolefin jacket, which is our CR series, and that is for mild solutions and also for physical protection. If you get into more heavier corrosives, then we'll go with our fluoropolymer outer jacket, which is our CT option. So it's always nice to know, and almost a must to know if there's any corrosives present and what are those corrosives, so we can determine the proper jacket that goes on the heating cable. Safety factor, standards 20%. If you're dealing with unknowns, if you have if you have some information, but you don't have all the information that you think you need, when you're talking about insulation type and thickness, maybe voltage, maybe the maintenance temperature, they say, it's said between 70 and 100 degrees, somewhere in there. If there's some unknowns, you can always bump this safety factor up just to be on the safe side. So that's the basic information that's needed for an accurate heat trace design. So with that, we're going to take that information, we're going to roll into our Chromatrace program, and get it open here. And we will go through a line. So, well, I'm sorry. We need to back up, don't we, D? I'm sorry. Let's go back to where. Sorry about that, D. I jumped the gun on us.
No, it's okay. You want to tell them where to find it here?
Yep, there you go. So our Chromatrace program is on our website, just chromalox.com. And you'll just go to our homepage, and then you'll go to resources and support. And right down here in the middle, you'll see software. Click on the software button, and it's the top software program, which is the Chromatrace 4.0.29. The next, once you hit that selection, you'll confirm you want to download it, and once you hit the download button, you're going to be asked to register. So whenever you register, it's your basic information, your email, phone number, It's going to ask you your annual use. It's going to ask you all that. But what is really, really important is that you do register the software, because what that does is we're constantly updating the software and we're adding new things. If there's ever a bug found, we may go back and fix it and release a new version. Whenever you open your existing program, you're going to get an alert that says there is a new version available. Or you might get an email that says, hey, new version of Chromatrace is out. Please download here. So please take the time to register when you do download the software. And that's the contact information that we were just talking about there. So after you have it all downloaded, there's a lot you can do with this. We've got some live demos online. Other than the training today, we have live information you can look at. We've got tutorials, which I'll show you where those are here in a second. But there's a lot of information there for you to go and grab and work at your own pace if you like. So with that, we'll jump over to the actual program. And whenever you start Chromatrace, what you'll do to start a new project is just come over to New, and we can select whatever we want. We'll just call this Teams Training 1. And what you'll get is you'll get a default line number. So it always starts out with a default line number. So if you click on that line, it's going to open our main screen. And at the top, we have 4 tabs, and we're going to work through each one of these real quick. But the first one, the common tab, you've got your line number. If you don't know what it is, like I said, we'll just call it 2-inch caustic line. The parent and child section, this is used if you're going to have like a main header with multiple lines dropping off of it. You can do parent and child, so it actually calculates the number of T-splices you might need in a circuit. We're not going to get into that today. We are going to do another training, which is I guess kind of 2.0, where we do a more advanced training with more features that are in the program. But today we're going to just try and keep it simple and basic. On the right-hand side, we have our temperatures, and all this is what we just talked about on that design sheet. So we'll just click on and change our maintain temperature. We'll set that at 70. Our minimum ambient, we'll just say that's 0. And you'll notice whenever you change your minimum ambient, it's automatically going to change your startup. And that's the same as the minimum startup ambient that was on that sheet. So you always want to make sure these two numbers match. Safety factor, we'll bump that up to 20%. Your maximum ambient defaults to 110 degrees. That is what that is for is in a runaway condition. If your control failed, it's going to look at the maximum ambient, and it's going to calculate a sheath temperature, which you can see down here at the bottom. Here's an uncontrolled temperature. That is at a 110 degree day if your system just ran away, and the only thing present was 100% voltage. So I usually leave it at 110 degrees. If it's lower than that, feel free to change it, but 110 is pretty much a standard. Maximum exposure, it's just like we just talked about. We want to put that in there every time. We want to know what the max exposure is of that line. And as you can see, with our heating cables, they're rated basically by the exposure temperature that they will be able to withstand. Right now, if you look down here at the bottom under this results tab, this is always running. You know, it's live. It's you don't have to take and input all your information and then hit a design button so that it gives you a design. This thing is always running in the background. So right now, with the information we've inputted, it's given us a SRL cable, which has a maximum exposure temperature of 185 degrees. If we bump this up to 300 degrees, it's going to change our cable type to SRM, which is good to 420 degrees. So we'll take that back down to about 150 just for what we're doing. But that's why your max exposure is there. Max operating temperature. This is if you have a max design temp or max operating temp, and you want to try and keep this heating circuit from overheating, you can plug in that max operating. The max allowable would be the maximum, absolute max allowable that pipe can see. So those two I usually leave as the default because there's not a whole lot of times where we're dealing with that critical of a process that we need to worry about these two parameters here. Back over down in the middle now on the heater side of it, the electrical, you can plug in whatever voltage you want to plug in up to 277 volt with our self-regulating cables. So you could just plug in 208, or for this instance, we'll plug in 240. Your main breaker size, that's exactly our max breaker size. It's exactly what we talked about a while ago. If you only had a 20 amp breaker, then we would select a 20 amp breaker if that's all you had available. Phase to neutral, phase to phase. I haven't really figured out a lot of difference in these two. Whenever the program was developed, we were going to add on our panel selections where it lays out a complete panel for you as well. And that's where I can see this coming into play. But knowing it's 240, we can say phase to phase. If we took it back to 208, we know that would be phase to neutral. So this is not going to make a difference in your overall heat trace design. So if you're not sure, don't worry about it. The heater selection portion, it's going to default to a self-regulating cable. You can come in and you can force the cable type. You can force a constant wattage. You can force an MI cable or a series long line cable. But today, since we're just trying to keep it kind of basic, we're going to keep it on a self-regulating cable. You could, like right now, it's giving us an 8-watt cable based on our design parameters up here and our voltage. If you had 10-watt cable on site already and you wanted to see, what would happen if I used 10-watt cable, you could actually select and you could force which cable you wanted, and it's still telling you that the design is okay. Anytime the design is not okay, you'll get an error message. So you can do that. Attachment method, that's used for nothing more than your bill of material creation that the program does for you. Don't concern yourself with it. It'll default to fiberglass tape. If you select, which we'll get to in the next screen, if you select a PVC pipe, it's automatically going to add aluminum tape. If you select MI cable, it's gonna default to your stainless steel tie wire. So don't give that too much thought if you're just trying to get a basic design. Number of circuits, I'll come back to this, and trace ratio, I'll come back to this in just a second. But we'll switch over to the next tab and go to pipe and insulation. Here's all your choices for the type of pipe that you're actually heating. So you just select on the pipe you're using. Here's all your pipe sizes. select whatever our pipe size is, and then the actual pipe length. And we'll put this in here at 100 feet for now. And then this is where our heat sinks come into play, where we were talking about the additional allowances for equipment. If we had 2 gate valves, we can plug that in. If you'll notice down here, it added, remember, this is constantly running in the background. So our total cable length is now 105 feet. So it's added 5 feet of cable for 2 valves to your 100 feet of pipe. On pipe supports, we always have to allow for pipe supports if they're not insulated. If it's metal to metal contact, that is a huge heat sink. And you can do it if you know the number of supports, you just simply enter the number of supports. If there were 3 on this one, you would just enter 3. If you weren't sure, you could actually select spacing, and you could estimate that every 15 feet, we're going to have a pipe support. Just if you were trying to get a quick estimate. And you can see it's slowly adding to our total cable length. Additional cable, you can do one of 2 things. I've seen a lot of people that will take, if they don't know their heat sink, they don't know how many valves yet, they don't know how many supports yet, how many flanges, they'll say, look, for now, let's just add 20% cable to allow for the additional heat sinks and additional equipment. So you can add that percentage in here, or you can add it in as an amount. I always add at least about 6 feet, sometimes 6 to 10 feet. And that's not because I'm trying to sell more cable by any means. That is so for terminations on your power and your end termination, you're going to have some scrap. And it's usually 2 to 3 feet at each end. If you have a splice kit, you're going to lose, about 5 feet of cable. By the time you pull it up through the box and get everything stripped and trimmed back, you're going to have some waste. So now this will play into your overall design criteria, but the one important factor is it does go into your bill of materials, so that it is accounted for. So I always add about 6 feet there. So that's our pipe and insulation screen. Go to the 3rd tab, which is environment. We have different approval regions that you can select. The USA, obviously, we're a lot FMUL, Canada, CSA, CUL, Europe, ATEX, and then we also have IECX, for more of a lot of global approvals that you have now. So if you selected US and we had a hazardous area, it's going to show us the different areas. If we selected Europe, it's going to give us zones. So that's just whatever region you're in, you can select it. So with the hazardous areas, we'll leave it like it is right now here. We'll call it Class 1 Div 2 or D. This can be changed. If it's a Class C or a Class B for that matter, you can switch and add it in there. Under design options, you do have the option of entering a T rating. If you don't know the T rating and you just have an auto ignition temperature, you can enter that information in here, and that's going to prevent you from designing a heating cable that is going to have a sheath temperature that's going to exceed the auto ignition temperature. So if you don't know your T rating, but you have a auto ignition temperature rating, you can insert it here. Sheath temperature calculation, we always leave this at a stabilized design. I'm not even sure why we have a control limit design. I've never really used it that much. The stabilized design is always a little bit more accurate for me. So I keep it at a stabilized design. Up in the right, you've got the location, indoor and outdoor, like we talked about earlier. And all that's going to do is drop your wind speed. So we'll leave it at outdoors. Leave our wind speed at 20. And then this is where we were talking about the corrosive environment. Right now we're showing, if you look at our cable model that's selected, we're showing a CT model cable. The C in our part numbers stands for the braid, which is mandatory now by NEC that you must at least have a braid. And then the T is for our fluoropolymer, for our corrosive environment outer jacket. If we change this to a mild, like water or weak acid base, something like that, it's going to change our cable model to a CR, which is our thermoplastic jacket. So that's where our chemical exposure comes in, and it will select the type of jacket required. So for design and caustic here, I'm going to keep it at strong. Miscellaneous information. This is for you to fill out however you like. Change code, you can put whatever you want in here. A drawing number like we talked about on the previous sheet. I like to use the area name as actual, if we had multiple circuits and we want to group them into panels, I like to use this, and I'll call this, just for instance, we'll call it heat trace panel 1. And we know that this heating circuit is going to go into this heat trace panel. Comments, you can put whatever comments you want in here. You can say need more information, or need to add, verify pipe link, something, something to that nature. You can put whatever comment you want in there. The reference number, that's totally your judgment as well. If you have a reference number you want to add, maybe it's a pipe class, maybe it's a revision, maybe it's something something specific that you want to add, you can add it in here. As far as fluids, I'll always keep this on water. The program was actually designed to do heat up calculations, and that's where the different products, different fluid products come in. As you know, being an electric heater manufacturer, as well as electric heat trace, when it comes to heating up a product, heat trace should never be your #1 choice. It's just really not built for it. It can do it under certain circumstances, but it's just not built for it. So we always leave this just at water. If we go to the next tab, we go to our accessories. The component family, we have several different component families. We've got our DL series, our HL series, and that's for Class 1 Division 1 areas. Our JB series, those are components for MI cable. Our U series, which are our standard kits and components that we use every day. And then we have a long line series cable components that can be selected as well. This usually should default to U series because that is predominantly what is used in the market today. The power kit option, you have the choice of lighted and non-lighted. I usually always use a non-lighted kit unless specified. The in-seal kit, you can use non-lighted, lighted in-seal, or just simply an above the insulation in-seal, which to me is fantastic to have it above the insulation. If there's ever trouble with heat trace, it only happens normally where the human hand has touched it, and that's at the power connection kit, a T-splice, or at an end termination. If you go out there to troubleshoot a heat trace circuit, the first thing I'm going to ask is, how long is this circuit? Where does it start and where does it end? If that if that end termination is not labeled and it's under the insulation, we're going to have to tear off a bunch of insulation to find the end seal, because that could be possibly where the problem is. You get it outside the insulation, you walk right out and put your finger on it. So I encourage everybody to at least use an above the insul kit. Temperature controls, very simple. Ambient sense or line sense. If we're doing freeze protection, we'll be doing ambient sensing. If we're doing process control, we'll be doing line sensing. Your controller type, you can do a mechanical thermostat or a local electronic thermostat, or one of our single or dual loop panels. So that's where these come in. We're going to leave this at line sense, and we'll do a local electronic. And we're going to use one of our DTS, which is a combination power connection kit digital thermostat with a built-in RTD. So the 4 separate box, this would be if you have if we did line sensing and we did a mechanical like a thermostat, and we selected one of our regular mechanical thermostats, you would need to force a separate power box, because that particular model will not allow you to terminate the cable inside of it and use it as your power connection kit as well, your power and thermostat. So we'll tell you what, we'll just leave it just like it is right there. So with that, that's all the input that's needed. You can see down here that we have no error messages. We have a design. It's giving us our heat loss, the output of the heating cable at the temperatures that we inputted, our total circuit length, our startup current. Keep in mind, self-regulating cable has an inherent inrush current associated with it. So that's what we base our maximum circuit lengths on. So that's your maximum startup current. This gives you your actual transformer load for this circuit. Like I said, here's your heat loss, trace ratio per cable, trace ratio. That's no more than the number of passes. And then the number of circuits for this line, we just have one circuit. And I said I was going to go back to it, so I'll go back to it so we can show you. If I put in a length of 400 feet here, we're going to get an error message. And that error message is going to say your circuit length is too long. So what we have to do is we come back over to common, and we say number of circuits. We'll go with 2 circuits. It's still too long. So we have to go to 3 circuits. So now it's telling us that you've got 3 circuits. So anytime you do that, it's going to show you, anytime you do an input that it doesn't like or won't spit out the correct design, it's going to give you an error message. And it will tell you what that error message is. So with all that, you've got your information over here. Since the minimum control temp, 70 degrees, max control temp, that's just because we have a line sensing thermostat on it, and it's going to maintain it here. You're going to have a little bit of swing in it with the play, a few degrees maybe, but that's your max. Your uncontrolled temp is if you did not have any control on this whatsoever. That's how hot the pipe could get with the cable that is selected. And then your sheath temperature, that's the maximum that your sheath temperature could get on a 110-degree day with full voltage on your heating cable and no control. So that's the results. You can go directly to your bill of materials from here, and you can see everything that's needed for this heat trace circuit. Now we can go from here to our reports. One other thing I'll touch on real quick, up here at the top is project settings. This is nice. You can come in and put the project name, the reference number, just like we did on that sheet before. This is where all your information comes in. You can do imperial and metric. If we go to metric, it's going to change everything to degree C. And it also puts everything in watts per meter. And as far as length goes, in meters. So that is there if you want to, metric. And then this is just other information that you can fill in. And what that'll do, and when I'll show you the report here in a minute, is that'll populate the header on the top of your report. So with the reports, you click the report tab and we can go to a simple bill of materials. And there's everything you need for that heat trace circuit. The reason it's doing that is because of that. You can go to a summary report, which gives you all the information for that one circuit. And what I was talking about earlier as far as panel goes is that I can sort by area name, and then it's going to tell me that this line is in heat trace panel 1. If I had multiple lines, it would designate heat trace panel number 1, number 2, number 3, or whatever I had it designated as. So it breaks it out into sections. So that's why I use that one. Another great one to use is the detail report. This is every single piece of information that we inputted into the software, and also what was the result that the software gave us. This is everything that's on in the program at that time, plus your bill of materials. There are some other reports. All the reports can be exported to PDF, Word, or Excel. There are some other reports like electrical report, mechanical, thermal. They just give you different information. This is going to show you some of your temperature information on the way it's calculated based on the thermal inputs that you put in there. One more thing we'll do real quick, which I find extremely beneficial, is if you have multiple lines where you may have 20, 30, 40, 100, 200 lines, and you have a line list. If that line list is in Excel, you can import that line list into the program and not go through everything and input it all at one time. So you would simply come over here to import, and we want to import lines, and we'll go here. I've got a sample, and we will open that up. And what it's going to do, it's going to pull the entire line list in. And then you'll come up here to the top, and you're going to name it whatever is in that column. So this is line name. We're going to leave this unassigned. This is drawing number. It's already there. We'll leave this unassigned, but you can assign it if you want something else. Pipe diameter. It's already there just because it's my sample list, but let's just say this was maintain temperature. All you gotta do is say, okay, that's our maximum ambient temperature. But we know that's actual pipe length, so we'll leave it at pipe length. And then you can do your number of valves, supports, flanges, additional cable. You can, if you had a spreadsheet that didn't match up already, all you do is come up here and change what you want to assign this column as. Here's your fiberglass type installation, all your temperature information, everything's all here. And once you have your column, your header identified as to what you want it to be, all you do is click import, and there's every one of those lines already calculated and designed. If there was a problem with one of them, it would give you an error message. It would flag it here as an error. So you would simply go click on that line and go to your messages, and see what the error message was and correct it and move on. If you have another one, move on to it. But that's importing, 50 something lines within seconds rather than going through and doing the input one at a time. So from here, now if we go to a report, there's our report. It just imported and designed every single one of those lines based off of that line list. We could go look at our bill of materials, and there's our bill of materials based on everything we just imported. And that's the basics of the program. One other thing I will show you is under the help menu, there are tutorials if you want to dig a little deeper into the program. If I skipped over something, if I went too fast on something, you want to go back at your own pace, here's all your tutorial information here. And like we referred to earlier in the presentation, there are trainings online that you can reference and look at. So all the information's here. If another really good thing about it, if you run a design and you're not really sure about it, and you want one of us to double check it, you can always email the actual Chromatrace file, because every time you create a new project, it creates a file. If you email that file to me, I can open it up, we can share screen, and we can say, hey, look, if we change this, we can get this result. Or, if you ask, why am I getting this error message? I can pull up what you actually inputted, and we can walk through it. So I believe with that is all I had. And this is, like I said, this is just kind of the basics of the program. It does a lot more. And in the very near future, we're going to do like a 2.0, I guess, and we're going to dive a little deeper into the program. But that's all I had. Thanks everybody for jumping on, and I'll throw it back over to Derek.
Great, Charlie. Thank you. Thank you. Get a little feedback on your side. Okay. Now we'd like to move on to the question and answers. Had a lot of questions submitted while Charlie was presenting. So Charlie, if you're ready, we're going to walk through some of those. Probably need your input on a lot of these. Question about the worksheet that you went through at the very beginning. Yes, it's available. We'll provide it with the recording, no problem there. But it's available on the website. We'll send it out with the recording as a summary after the presentation's over. Several questions about that. Here's an interesting one for you, Charlie. Does the attachment method of the heating cable to the pipe affect the inrush?
Yes, it does. If you use aluminum tape as your attachment method, it will change the input or the output of the heating cable, which will in turn affect your inrush. So if you were planning on, say, just putting heating cable on a tank and you were only going to use aluminum foil, it will affect the output of the heating cable having the aluminum tape over the top. So yes, it will affect it if you're not doing a pipe design, and that is something we can cover more of, because we didn't even touch on the tank portion of the software. But yes, the answer is it absolutely will.
Okay. Yeah, maybe something we cover in a future training too, but something to definitely take into account. And then the next question, actually we had this one before, a form, you showed how to upload line lists into the program. Do we have a standard form to provide to fill out? I think we have one. Most of the time we get those from customers, but Charlie, stop me if I'm wrong, probably something we can put together pretty quickly and send out.
Absolutely, no problem. We can actually follow up with that design worksheet. I already have one put together, and the one I put together is probably cheating a little bit because I actually added in for valves and all that, and on the majority of line lists that we get, you don't have that information. So we can absolutely supply you with a blank one to go in and fill in the information, because it's very time consuming to go in and input one by one. It's a lot quicker to go through and fill it out in Excel and then import the whole file. So yes, absolutely, we can supply that.
Great. Well, we will put that in the summary as well. Another question was about foundation heating applications. Now, I know I just done a few recently. Is this something that the program can handle? And if not, how do we handle that as Chromalox?
Yeah, this particular program does not do foundation heating. This one concentrates on industrial, which I know there's also industrial foundation heating, like for LNG tanks, those type of things. But no, this program will not design foundation heating. We actually still design those in-house with our application engineering group in Tennessee, and we take those one at a time and address them. But unfortunately, there's not a program that we have that I'm aware of that does foundation heating.
Okay, good question. Next question. I know you touched on it a bit on the program, but the control limit design. Can you explain that a little bit more, or is that something that's has an effect? The control limited design.
A control limited design just means that you're going to add a control, some type of control on the line itself to limit the output of the heating cable. That's all a limited design, control limited design is. It's, if you don't want, like I don't think I brought it up today, but like a corn fructose syrup line, where you don't want to exceed 150 degrees or 160 degrees Fahrenheit, whatever may scorch the actual product. You can use that control limited design and say, look, I never want this pipe, even in a runaway condition, to reach this temperature. And by doing that, by adding additional control to it, you can come up with that end result. So that is what a control limited design is basically keeping you from over designing a heat trace circuit.
Excellent. Now, this next question was I never thought of, but will Chromatrace allow a user to complete heat loss calculations using composite insulation, i.e. different layers types? Is that something we come across, or is that something that's not incorporated in Chromalox, the Chromatrace, I should say?
I would need to go back and double check. At one time, I believe you could select user selection on your insulation. And I do not see it now, but you could actually go in and insert your own K value, whichever you had from your composite. But no, it will not allow you to do a composite design where you have a multi-layer insulation. It will not do it at this time.
Okay, so not at this time. Okay, kind of a straightforward question. Does Chromatrace do cool down calculations?
No, does not.
Okay. And the final question that was submitted, if I have a fluid that doesn't appear in Chromatrace, what do we do? Or does it affect?
You can forward that to your outside sales rep or to me directly, and what we can do is take that fluid and look at the properties and find something comparable that we can use it for. But like I said during the presentation, whenever you're actually maintaining it, which is all we're trying to do with the program right now, is do temperature maintenance. Fluid really doesn't come into play because you're really looking at the pipe temperature. But if you do have something that's not listed, by all means reach out to us and we can look at the properties and match it up.
Excellent. Okay, that was the last question submitted. I really appreciate everyone for attending, and hopefully everyone, got some good insight out of this and learned something. And Charlie, great job. Appreciate it. Like I said, this will be first of many, I hope. So I welcome anyone to continue to submit questions or thoughts or even ideas of things you'd like to see in the future. So with that, Charlie, do you have anything else for the group?
Nope, that'll do it. Just want to thank everybody again for joining today. And like I said, we'll be putting together a little more technical 2.0 version, and we'll do a little design optimization on the next one, and hope everybody can make it back for that one. But thank you for joining today.
Charlie, thank you. And thank you, everyone. Have a great weekend.